Okay, class, welcome to lecture 2 for stats. Today we're talking about measures of spread. So I'm trying a different angle out today because last time I realized that it just recorded the top of my head the whole time. So maybe this will look better. We'll see. Okay, so today we're talking about measures of spread. So last time, just to very quickly summarize, we wanted to think about the middle of the data, various types of middleness. That's what the mean, median were for. But we used the word like central. So we were thinking about what's the center of the data. And that's what the mean and the median are for. Different ways of thinking about the center. So now we're going to think about the spread instead. So we want to understand now what it means for things to be more or less spread out in terms of data. So we want to understand the typical distance between data, because that's exactly what being what thinking about spread should be, right? How spread out things are is really just how far away they are from each other. So we're just going to think about what the typical distance is between some data. Okay, so the first way to do this is the most boring way. It's called the range. It's also the least useful. You've probably done it before. So the simplest way to measure the spread of data is to calculate something called the range. And what is the range? Well, it's just the biggest number minus the smallest number. So what you're really doing is you're saying how wide it is. How wide is the data from beginning to end? And that's not really useful because it doesn't tell you how spread out things are all in between. It just tells you how spread it is from beginning to end, which is sort of not that useful. So just for practice, here's that data from the previous lecture. So I'm going to write it and it magically appeared again. So there it is. And let's calculate the range. So you literally just take the biggest number minus the smallest number, and in this case you get 32. So again, this really just doesn't tell us much because it just tells us how wide the data is one way to think about it. But nothing about how spread out the data is, like within that range. Okay, so that's the range. Next one is slightly better. It has a very fancy name. It's called the absolute mean deviation. And it sort of makes perfect sense because it's just doing exactly what we want. So let's find a better way to measure spread. So what we're going to do is literally what we want to do, which is we're going to measure typical distance from the mean. So this is nice because it'll tell us how far everything is on average, typically, from the mean of data. And the way we're going to do it is by literally doing this. So it'll make more sense with an example. That's just always how it works. So let's do a nice little example here. So we're going to start off small. So here's just a couple of numbers in our data set, 2, 8, 10, 20. And what we're going to do is we're going to think about measuring spread from the mean. So we're going to think about how far things are away from the mean, which means, first of all, we better find the mean. So that's from last time. So what do we do there? We add our numbers up, and then we divide by how many there are, which is there's 4 here. So you're going to end up getting 40 when you add it up, and then you divide that by 4, which gets you 10. Okay, so the mean of this data set is 10. And what we want to do is think about how spread the data is by calculating distances away from the mean. So we're literally going to do that. So we're going to find the distance of each data point to the mean. So you might not have thought about what distance is, but it's really just about subtracting numbers. So how far is 2 from 10? So for example, 2 is the data point, the first data point, and the 10 is the mean. So I'm going to do 2 minus 10 to see how far away they are from each other. And I end up with negative 8. And I'm going to do that for each number. So 8 minus 10 is going to give me negative 2. 10 minus 10 for the next one is going to give me 0. And the last one is 20 minus 10. 20 minus 10, it's going to give me 10. So these are the actual distances to the mean. So if I want to know what the typical spread is, one thing I could try to do is average these distances. I could think about, well, on average, how big are these distances by calculating their mean instead. So let's try that. So we can then try to average these distances to get a typical distance away. And then that should sort of tell us how spread out the data is. But of course, last time we learned about the word average is sort of misleading. There's mean, there's median. So secretly, we're just going to do the mean here. So we're taking the mean of distances to the mean. That's the big picture. But in practice, it's not so bad. Okay, so let's do that. So let's take the mean of these 4 numbers here. So how do I take the mean of those numbers? Well, I just add them up, right? Well, something goes wrong. Negative 8 plus negative 2 plus 0 plus 10. So I add them up, and then I divide that by 4 because there's 4 of them. Now you have to remember how to add negative numbers, but you're going to get negative 10 plus 10 over 4. What's negative 10 plus 10? That's 0. 0 divided by a number is just 0. So what's going on here? This is saying that everything is 0 away from the mean on average. But that's not so useful because that would mean that there is no spread at all. But that doesn't seem to make sense because we can look at the numbers and that we started with, and they do seem kind of spread out. So that should not be the right answer. So we have to see what's going wrong here. So something's gone wrong, and it has to do with the fact that these are negative and these are positive or 0. Okay, so let's fix this. To fix this, we realize that we shouldn't really care if the distance is negative or positive. So what we do is we care about distance to the mean, but not if it's to the left or right. We don't care which one it is. And that's what negatives are telling us. This negative 8 right here is really telling us that our data point was 8 away from the mean to the left. And this 10 here is telling us that that data point was 10 away from the mean to the right. But we really just care how far away things are from the mean, not whether they're to the left or to the right, just how generally far they are. So what do we do there? We don't care about these negatives is the idea. We're going to get rid of those negative numbers. Okay, so let's do that. So to fix this, we just make all the distances be positive. So a very simple fix. So we take our distances that we had, and we say, I don't care if they're to the left or the right, so I'm just going to make them all be positive. And of course, if they were already positive, it doesn't change anything. And then we're going to average, because now what we're really doing is we're really averaging the distances. So I'm going to do the same thing I just did, except now it's going to work better. 8 plus 2 plus 0 plus 10. Then there's 4 of those numbers, so I divide by 4 to get the mean. That gets me to 20 over 4, which is 5. So then this is saying that on average, the data points are 5 away from the mean. That's the idea. All we've done is averaged the distances to the mean. So that number is 5, and so that's what we're saying. Okay, and then this number has a fancy name. It makes it seem a lot harder than it is, but it's called the absolute mean deviation. Deviation comes from just saying, it's just another fancy word for how far away things are. And absolute actually comes from the word absolute value, which is secretly what we're doing to make numbers positive, if you happen to remember that. If not, don't worry about it. Just a little extra fun fact for a fun class. Okay, so we should practice some more. Let's do one more. So let's find the absolute mean deviation, which I'm going to shorten for time, for another very small subset, very small data set, which I've chosen to be quick to add to make our lives easier. Okay, but then we're going to analyze it a little bit. So then decide if this data is more or less spread out than the previous, which I'll just rewrite here to remind you. It was 2, 8, 10, and 20. So before we even do this, what we should try to do is think about like which one of these seems more spread out than the other. So you should think about that really quickly. And then our answer should hopefully go along with our intuition. So whichever one feels more spread out should have a bigger absolute mean deviation. This number should be bigger for the one that's more spread out, because a bigger number should mean more spread. And that's it. That is what's going to happen. Okay, but let's do the actual calculations. Okay, so first we need the mean. 9 plus 11 plus 8 plus 12. There's 4 of those numbers, so I divide by 4. That's going to be 40 again over 4, so I'm still going to get 10 like last time. Then I'm going to calculate the distances. So I'm going to do 9 minus 10, 11 minus 10. So we can already see how each of these distances away from 10 is smaller than in the other example. So I got -1, 1, -2, and 2. Then I'm going to make them be positive. If they're already positive, then that's great. Don't have to worry about it. And then I'm going to take the mean of those 4 numbers. 1 plus 1 plus 2 plus 2. Divide that by 4. And what is that? 6 over 4, which is, I believe, 1.5. So this is the absolute mean deviation for these numbers. And notice that it is smaller. So in fact, this data is less spread out than the other set of data, which hopefully you could intuitively see that these numbers are sort of grouped around 10 much more than these ones down here. They're all kind of far away from 10, except for 8, I guess, but the other ones are kind of far. Okay, so our intuition matches our actual answer. That's always a good thing. All right, but unfortunately, people don't use this measure of spread. It's not very useful for very high level math reasons, so you don't see it often. So we have to learn a different one, which is a little bit harder, but more people use it. Okay, so this is called variance. So this is another measure of spread. It's very similar to absolute mean deviation. In fact, it starts the same way. So it starts the same way as absolute mean deviation. So all we're going to change is how we make numbers be positive, how we change those distances into positive numbers. So let's start with the example we've already done so we can see the differences. So 2, 8, 10, and 20. So we're still going to find the mean first. And we already did that earlier, but I'll remind you that it's 10. So that step's the same. We're going to get the distances. So that's going to be the same again. So you get all 4 of these guys. Okay, and now instead of just making them be positive by just changing them into positive numbers, there's another way to turn a negative into a positive, and that is by squaring them. So now that's the difference. So now make these positive by squaring instead. So what does squaring mean? Well, you might have to remember, but it just means do this. Multiply it by itself. So -8 times -8, the negatives cancel, and that's why the negatives disappear when you do this. And then you do this to each one. So -2 squared gets you +4, 0 squared is still 0, and 10 squared is 100. And then the idea is we think of these as our distances, our typical, all of our distances from the mean. So now we average these guys. So we find the mean of these. And that's the last step. So 64 plus 4 plus 0 plus 100. Divide that by 4. So I'm going to use a calculator to cheat here. 168 over 4 is what you get, and that's going to be 42. So one thing is that, so this number is called the variance. So the variance is 42. But one thing to note is how different it is from the absolute mean deviation in terms of size. So 42 is very big, and it's supposed to tell us like the average distance, the average spread. But we got 5 for the absolute mean deviation, which is much smaller. So why is there such a huge difference if they're both supposed to be a number that tells you how spread out the data is? So that's one thing to think about. So why are these so different? So it's just a mathy reason, but I like math, so that's what I'm going to talk about. It's really just because when you square something, it gets really big if it's already big. So squaring big numbers makes them extra big. So what variance will do is exaggerate big distances. So large distances get exaggerated. And what this means is variance is not so good when you have big distances. So we have to do something to fix this. But it won't be so bad. Okay, so variance is not so good when there are large distances. All right, let's do one more example where it's much better because there's less spread, and we already did this example earlier actually with absolute mean deviation. So let's find the variance for this other set that we already know is supposedly less spread out because we found a very small absolute deviation, absolute mean deviation. So we'll see here that the variance much more closely matches the absolute mean deviation. Okay, so the mean is still 10. The distances, just like before, do the same thing. So you're going to get -1, 1, -2, and 2. So I'm just taking them from earlier instead of redoing that step, but that's just subtracting the numbers from the mean. And then I'm going to, instead of just magically making them positive, I'm going to square each one. So -1 squared is -1 times -1 is +1. 1 squared is still 1. -2 squared is 4. And 2 squared is 4, 2. Great. And then I'm going to average these things. By taking their mean. And that'll be the last step. 1 plus 1 plus 4 plus 4. Divide that by 4. It's 10 over 4, which is 2.5. So notice that this is much closer to the absolute mean deviation than in the other example. That's because it's less spread out, so the variance doesn't grow giant. So just to remind you, it was 1.5. So 2.5 and 1.5 are much closer together versus 42 to 5, which was for the other example. Okay, so again, the thing we just calculated is called the variance. Okay, great, so that's the variance. So how do we fix this size issue? That's the last thing in this video, and it's not so bad. So let's do that. So to fix the size issue with variance, we we just do something at the very end. We square root at the end. So the square root of a number is sort of like is exactly doing the opposite of squaring it. So it sort of cuts it by the same amount. It shrinks it by the same amount, which is great because that's the problem is variance made things too big. So that's all we're going to do. So for the first example, for this guy, 2, 8, 10, and 20, we figured out the variance was 42. So all we're going to do is look at the square root of 42. And then this number has a fancy name as well. It's called the standard deviation. So this word you've probably heard before. This is the measure of spread that everybody loves, even though it's slightly more complicated than absolute mean deviation, which sort of makes more sense. This is the more widely used one. And so it's just variance, except at the end, you now square root. So 6.48 is the standard deviation for this data set here. So notice it's much closer to 5, which was the absolute mean deviation. So that's great, because then they sort of match up a little bit better in terms of they both tell you like, okay, it's kind of spread out, versus the other one, which is 1.5, tells you, okay, not spread out at all. So let's do that other example too. Just to finish it up. So for this guy, 9, 11, 8, 12, we had the variance was 2.5, correct? So then what's the standard deviation, which I'll abbreviate like this? Well, it's just the square root of 2.5, which of course you use a calculator for, unless it's a nice number that you can take the square root of in your head. This one is not, so 1.58. So now this is very close to the absolute mean deviation. Which was, I think, just 1.5, right? So these are very close together now. So what this is telling us is that they both do a good job of measuring the spread. They're both roughly around the same size in each case, but for some reason we like standard deviation better in pretty much every situation. It's really for high-level math reasons that if you want to know about, I will tell you separately, but otherwise it'll remain a secret and you'll never know unless you keep taking higher math classes. Okay, so let's see, just to summarize this in the last lecture, the mean is generally the most used measure of center. So most people think of the mean as being the middle of the data or the average, while the standard deviation is the most used measure of spread. So they sort of go together. And it makes sense that they go together because when you calculate standard deviation, you are in fact using the mean a couple times. But the main reason that these are the most used is because they are mathematically nicer, which again I hinted at, but for our purposes, we can't really get into that. Okay, so that's it for today. So see you next time.